Okay, so we will be solving the few questions that were sent to me. Okay, so the BJT region of operation, let me just put a quick conceptual part. So BJT's region of operation. So you first bias the BJT. Okay, so with DC voltages, the BJT is actually biased to perform in any one of the regions. Okay, so how it will behave. So let's say one second. Um, just try to Okay, so what we do is we will use, so BJT is a transistor, right? So what happens is that whatever voltage you apply in the input, according to that, the output current should change. Okay, that is the basic idea. So what will happen that you will have to bias the BJT in any one of the region as how you want to use the BJT. So for example, I want to use the BJT as amplifier, which is one of the widest usage of BJT and MOSFETs, right? So what we do, we will, so the BJT itself will not behave as an amplifier suddenly, right? You will have to put some voltage across it so that it behaves like an amplifier. So what will happen is you will you will give some kind of DC voltages. So now in BJT, it is the three terminals are there, B, E and C, base, emitter and collector, right? So what you do, you put some voltages, DC voltage, and you make sure that it biases, right? So whenever your VBE is greater than equal to zero point 0.6 or zero point 0.7 volts, as is given in the question, okay, or it depends on the device. If it is greater than equal to this, then the input is said to be forward biased. Okay, in this condition, input is forward biased. Now, depending on whether output is forward biased or not, or the output is reverse biased, this now will behave as an amplifier. Okay, so now suppose I give a voltage, some voltage I will give here also, VCC, to bias the collector to emitter node. Okay, so suppose I put a voltage such that the condition turns out that VCB, that is this voltage, VCB is positive. Okay, VCB turns out to be positive and it is greater than the normal saturation value. So, sorry, VCE will be greater than the saturation value in this case. Okay, so normally this second part we don't check. What we do, we see if VCB is positive or not. Now, why is this checked? So, the transistor is nothing but like this, right? So, suppose it's also this is NPN, right? So, it is nothing but like two diodes. Okay, so C and B. So what does C and B positive means? VCB positive means this diode is reversed bias, right? So if Okay, so yeah, so with this diode is reverse bias. Now if this diode is reverse bias, that means it is output is reverse biased. Now in this case, it will work as in active region and it acts as an amplifier. So if it is asked, then you should first find out whether this VBE is 0.7, it is getting fulfilled or not. Okay. So how will you find that? In question there will be some voltage here, there will be a resistance here. You now have to find out whether a current can possibly flow from here, right? So if the current can possibly flow from here, if it is satisfying the KVL equations, then this is forward bias. Then from the knowledge of beta, you find the IC because you assume it is an active region. So what is the process? The process, if in question it comes, first you assume it is an active region. Okay, you find IB taking VBE as 0.7 or whatever is given. Okay, and then from knowledge of beta, you find IC. Now apply KVL on outer loop and find VCE. Now VCB will be VCE minus VBE. Now from here you find, check if VCB is positive, right? So if VCB is positive, your assumption is correct, positive. If true, then your assumption is correct. If this is not true, then what will you do? You will go back. Now what will you do? You will assume if not true. Take VCE as VCE sat, which is normally equal to 0.2 volts or whatever is given in the question. Now you find equation for IC from here. And there will be one equation for IB from inner loop. Solve both. And then whatever you get is your true answer. Because now the transistor is in saturation, you cannot use the formula IC equals to beta IB. Cannot be used in saturation. Okay. So suppose I have a question. Like this. RB, suppose it is given 1K, 2K, 2K. And this is 10 volts. This is, let's say, 2 volts. Okay. Or let me make it 5 volts. Let me make it 5 volts. Okay. So what will you do for region of operation and all those stuff? What will you, suppose they have asked you to find IC and everything. So what will you do? You will take IB here, IC here, and this is IB plus IC or IE, right? Now beta is also given, say 100. So what I have written in the steps is, first I will put a loop here. So 5 equals to IB into RB. So IB into 1K plus IE into 2K. Right? So 5 is equals to IB into 1K plus IC plus IB into 2K. So this is nothing but 3 times IB plus 2 times IC. Now remember, if your units are in volts and kilo ohms, your answer will automatically be in milliamperes. So you need not make any changes here. Okay. You can just solve it. That will save you time. So this will be your first equation. Now, if the transistor is in active region, what can happen? You can use IC equals to 100 times IB. Only for active region, right? So I'm assuming that it is already in active region. So I will take this formula, and what I'll do, I'll find IB and IC from here, right? And then this IC value I will use to solve this outer loop. So what will this outer loop be? 10 equals to 2 times IC plus VCE plus 2 times IC plus IB, right? This is the outer loop. Now I know IC and IB from the previous step. I have already found it from equation 1 and this one, right? So I will just put the value of IC and IB. I will find VCE from here. Now suppose after finding VCE, I see that the VCE value is very down, such that VCB comes out to be negative. Suppose. That means my assumption of active region is wrong. And now what I will have to do? I will have this one equation here, equation 1. This middle steps will be eradicated. We cannot use this. And then I have this equation, equation 2. I will use VCE value. So 2IC plus 0.2 plus 2 into IC plus IB. Now you have this as equation number 2, the previous one equation number 1, and you can solve equation 1 and 2. You can now solve equation 1 and 2 and find IC and IB. And you will find that IC will never be equal to 100 times IB. It will not be equal to 100 times IB. Okay? It will not be equal to 100 times IB. It will be something lesser than that. Okay? So now, this is how you solve for the region of operation questions. So to find the region of operation, you have to find the value of VCB. If VCB is positive, it is for NPN. Remember, VCB is positive for NPN in active region. And for saturation, it is negative for NPN. Now for PNP, it just becomes opposite. So VBC will be positive for PNP and VBC will be negative for PNP. And if you have any doubt in remembering this, then the way I did it, you just draw the transistor. You know it is NPN. So positive of diode here, negative here, positive here, negative here, and now C is here, B is here. So if I put a positive VCB, this diode is reverse bias. So here it is reverse bias. If I put a positive VBE, this diode is forward bias. So input forward, output reverse. This is in active region. So therefore I know for NPN, VCB positive will be active region. Now did you get it? Is it clear? So this is the trick to remember. This is how I remember. Okay. If I get confused, this is how I remember. So this is how the active region is to be found out. Then we will go to a question. But first, I just wanted to give a summary of the theory. So if you have noted it down, then I will move forward. So now there was a question that Chandrasekhar had shared. So in this question, you can see that 2 volts is given in the input, right? And VBE on is given 0.7 volts. So I'm assuming here it is 0.7. I'm assuming it in active region. I'm assuming there is 0.7 volts. So what is the voltage here? It is 1.3. 2 minus 0.7, 1.3. So if 1.3 is here, that means the current here is 1.3 milliamperes. Right? And beta is very large. So whenever beta is very large, that means IB is 0. Okay. So that means the same 1.3 flows from here. Now you find VCE. So E is already at 1.3 volts, right? So what is VCE? What is VCE? So VC will be 10 minus 1.3 into 10K, which is nothing but minus 3 volts. And VCE will be minus 3 minus of 1.3, which is nothing but negative of 1.6 volts. That means VCB is going to come negative only, right? That means the transistor is in saturation. The assumption of active region is wrong. The transistor is in saturation. For cutoff region, there will not be any flow of current. Okay, it will be off. So this was a simple question only. Okay. So now coming to the next question. Yeah. So this question also you see, beta they have given as 50, VBE they have given. Okay. So let me write plus minus 0.7 is VBE, beta is 50. VC SAT, they are asking to assume 0.2. So now I will assume it is in saturation. Let's see what happens if it is in saturation. Okay. So if it is in saturation, then it is 0.2 volts. You can also do it in reverse. You can also assume active region and arrive at a point where you know VCB is negative, and then you know that okay, this is in saturation. Okay, so I'm automatically assuming it is saturation for now. So if this is 0.7, this is 5 volts. That means from here the current flowing is 4.3 by 50, right? 5 minus 0.7 by 50 K is the current flow, right? And beta is 50, but I won't use that because I am assuming it is saturation region, right? So what I'll do, I'll use IC. Okay, so but RC is also unknown, right? So what is RC? 10 minus 0.2 by IC, right? So this comes out to be 9.8 by IC, right? And now the current that is there, IB, is 4.3 by 50, right? Now the maximum value that it can go is beta times IC. Okay, so what else can you do here? Any other way anyone can suggest? So let's assume it is an active region and solve, and let's see what comes out to be. So if it is an active region, so if the transistor is an active region, okay, what will happen? IC will be equal to 4.3 by 50 into 50, that is equals to 4.3 milliamperes, right? But again RC is unknown. Okay, so what can you do? So here you can make assumptions actually. Here you can make assumptions and try to solve it. Okay, so suppose so IC is 4.3 milliampere is flowing here. I have found from active region RC IC equals to 4.3 milliamperes is flowing. And in the options already there are certain values given. So let us try with 1K. So if I use 1K, then 10 minus 4.3, and that makes how much? 5.7, right? So that gives you 5.7 volts as VCE, right? So if 5.7 volts is VCE, then my transistor is in active region. So the first option, which is for RC equals to 1K, BJT is in saturation, is wrong, because we have just seen for RC equals to 1K, BJT is in active region. So this question was like, you see the options and then you can solve. Okay, so whether you take it to be saturation region or you take it to be active region, you can solve with this. So had I started with saturation, what will be the case? If I had started with saturation, okay, then what will I try to find out? Then what I'll do is I can do IC equals to 10 minus 0.2 by RC, and then I will put RC as 1K, and then it comes out to be 9.8 milliamperes. And from here 4.3 by 50, I know that IC should come out to be 4.3 milliamperes. And here I see that the IC that I'm finding is greater than the IC that I'm getting from the multiplying beta, and therefore it is not in saturation, it is in active region. So one of the condition is to check with beta times IB. Okay, so this both you can do. Okay, any of the condition you can take and you can check whether in what region of operation it is. Okay, so now next what I will do, I'll check with RC3K. So now suppose I have RC3K, okay, and now I have 10 minus RC is 3K and IC is 4.3. So 4.3 into 3K, and that will be BCE, and clearly BCE is negative, right? That means it is in saturation. So in option 2 only, I have found out that option 2 is correct, because RC is 3K and at that time BJT is in saturation region. So this question was kind of a designing problem, and therefore you cannot find it through KVL and KCL, because not all the information is not there, right? So what you can do is, the way I have shown you, that RC is unknown, IC is unknown, VCC is given. Here I am 50K is given, 5 volts is given, plus minus 0.7. So I know IB came out to be 4.3 by 50. I know beta is 50, right? And I just assume, I now just make an assumption that okay, let us say that beta is 50, therefore IC is 4.3 milliampere. I am assuming it in active region. And now let us check the options. And in options, RC is 1K. In options, RC is 1K. And for 1K, I will just put in the value and I will check what is VCE. And I found that VCE came out to be positive. That means it was in active region. And in option, it is given in saturation. So therefore, that option cannot be the answer. And therefore, again, I will check the next option, where RC is 3K and VCE came out to be negative. And therefore, it is in saturation region, and my option matched. Okay, so this is how you should solve it in GATE. You can take the help of the options. Okay, so there is one solution that I found over internet, just wanted to show you guys. So let me just share my screen again. So let us see what they have done. I haven't seen the solution, whether they have solved the way we are solving. So what they have taken is, in the linear region, IC will be equals to I beta times IB. VB they have taken. Okay, IB they found out same way. VC is there. Now assuming everything, you found IC. Yeah, so they have basically done the same thing. Okay, they have basically done the same thing. You see here, they have taken the assumption if RC is 3K. So this value they have taken from the options, because in option 3K is there and 1K is there and all those things are there. So they have taken it from the option and then they are putting, because otherwise how will you know which value to put, right? So suppose this type of question comes for numerical answer type, then they will give you some hint, some value they will give you. They might ask you at edge of saturation. They will say what is the value of RC at edge of saturation. So at edge of saturation, you can use IB equals to IC by beta. This formula you can use at edge of saturation. Okay, so something will be there if that is a numerical answer type. But if it is an option based question like this question, you see, then they will not give you these kind of conditions, because they know that you can see the option and try to find the answer, right? Okay, so now going to the next question then. Okay. Yeah, so this is, I think this is a GATE 2011 something question. It was a pretty simple question. It's a good question. So this question, when you see, you will think that okay, something they have given transient analysis and all those things, but it is not like that. So what is there in the question? Okay, they have said that okay, this transistor is biased, and I'm opening the switch at t equals to 0. So earlier the switch was closed. That means earlier there is no capacitor connected. Now I am connecting a capacitor. And you see the voltages they have given. They have given -5 here and -10 here. So -5 here should not make you think that this is not going to work, because this is more positive than the -10. -5 is more positive than -10. So this is as good as saying putting 5 here and ground here. It is as good as that. Okay. So then what will you do? You just put one KVL here. So VB on is given plus minus 0.7, right? So when I put KVL, what will happen? 5 plus 0.7 plus 4.3 times IC. Beta is infinity. Yeah. So beta is infinity. That means IB is 0. Okay. So I'm directly taking IC. Okay. And 4.3 times IC. And then what will you have? You will have -10, right? -10 equals to 0. So what will IC come out to be? 10 minus 5.3. 10 minus 5.3 is nothing but 10 minus 5.7 divided by 4.3. So this is nothing but 1 milliampere, right? So that means the current from here, which is going from here, is 1 milli. And I have a source of current of 0.5 from up. That means the current which is going here is 0.5 milli. Right? So basic question. They have asked time at t at which Q1 leaves the active region. So the Q1 will leave the active region when the voltage here will change, right? What will happen? Vc is nothing but, you know, Cv equals to Q, right? So I into T upon C, right? So yeah, so what you are getting, 0.5 by 5 into, no, something is wrong, right? No, it's fine, okay, into T. Did I do any mistake here? Is it, it's correct, I think, right? So what is Vc, we have to find out, right? Okay, so now Vc value you should know. So to find the time, you should know the value of Vc here, right? Basically, the Vc value you should know. So how to find the value of Vc? You will have to find VCE for that purpose, right? Yes. So VCB, how to find VCE from here? So earlier when it was grounded, let me see what will happen. VC plus VCE plus 4.3, and then you have minus 10. So VCE is nothing but 5.7, right? And if this is 5.7, then what I'm getting VCE as, oh, there should be something else given. Okay. So VCE SAT is also given. Right. Okay. So till here you have understood, right? So VCE is going to be 0.5 into T by 5, and now they have said the time at which Q1 leaves the active region. So Q1 leaves the active region means I have to use VCE SAT. So VCE SAT is given. So I hadn't seen that earlier. So VCE SAT is given as 0.7 volts, right? So what I will do, I have 1 milliampere here. I have plus minus 0.7 here, right? And I need this voltage, I need VC. Okay, so what is VC? VC is nothing but 0.7 plus 1 into 4.3 minus 10. Is it? So this is 5 volts. This is clear, right? So now I will simply plug in the value here. So 5 equals to 0.5 by 5 into 10, and this will give you 50 milliseconds. If you solve this, you will get 50 milliseconds. So is this question clear or should I repeat it? Just have a look at it and see how it is solved.
VC minus 5 or 5 volt?
Sorry?
VC.
No, minus 5. Yeah, sorry. So I have taken the direction of current as wrong. So that's why. Okay. Yeah, good
Yes,
point.
ma'am.
Thank you. So this will be minus 5 volts here. Okay. VC is minus 5 and the current direction is like this. So 0.5 from this, and therefore 1 milliampere goes on here.
And 0.5 plus 0.5,
Right.
then 1 milliampere.
Yeah. Okay. So that's why, so even if you take VC negative here, there will, the minus sign with the current will cancel out. Okay, so T is 50 milliseconds. Thank you for pointing out. So have a look at the question. If any doubts, you guys can ask. Okay, so for the next question. So these kind of questions are no longer given. The voltage regulator questions I haven't seen much, but in this kind of questions are pretty easy. Okay, what happens is whenever there is a Zener diode, remember you have to reverse bias it. That is why it is there. So just reverse bias it. Take plus minus 3.3. Okay. Now if there is 3.3 here, they have asked the value of R2. They have asked the value of R2. Okay. Regulated voltage is 9 volts. That means what is the value here? They have said base current is negligible. So that means zero current here. Okay. So this is now nothing but voltage division. So this voltage here will be R2 upon R1 plus R2 into V0. So R2 upon 1 plus R2 into 9. This is already done. Now this I know it is plus minus 3.3. This I know it is plus minus zero point 0.7. Right? So what is the value here? 4 volts. So just equate it. 4 equals to R2 by R1. 1 plus R2 into 9. 4 plus 4 R2. 9 R2. 4 by 5 is this much K. So they have asked in ohms. 4000 by 5 is the answer. 800 ohms. Okay. So these kind of questions are no longer being asked. Even if you are asked from voltage reference circuit, you might be asked something which are basically related to MOSFETs, but I don't think they will ask you. Even if they do, it should be a simple thing. But do study current mirrors. Okay, current mirrors, simple questions you should solve, and voltage reference is one. But voltage reference, I don't think it they will give, but current mirrors can come. Okay. So I can solve one question from current mirror. I think I have it as well. Let's check. So now this is another question which is there. V in is given. You guys can see, and 12K, 4.8K, 5 volts. What they've asked transistor switches between cutoff and saturation region when T is large. The minimum value of common. Okay, so they have asked to find minimum common base current gain for the transistor to switch. So let's see how they have solved the question. So they have taken V in to be 2 volts. So that is, it is in saturation region, right? It will be in saturation in this point. So V in, if you take 2 volts, you just have to apply the KVL here. This is plus minus 0.7. And you will arrive at IB equals to this value, 0.108 milliampere, right? And now since you know it is in saturation because it is given in the question. This is plus minus 0.2. Okay. And if this is plus minus 0.2, you can find the current from here, which is nothing but 1 milliampere, right? 5 minus 0.2 by 4.8. Now this is 1 milliampere, and IB also you have. So you have IB, right, which is 0.108. You have IC, which is 1 milliampere, and you have, IE will be the addition of the two, which is this. But now for saturation, the condition is that this addition that you did right now, okay, the condition is IC sat will be less than alpha times IE. Okay, this is the condition. And you know that right now you found out that IC sat is 1 milliampere. It is less than alpha times 1.108. Okay, and from here alpha will be greater than some value 0.9. They are getting 0.908. So what they had asked was the minimum value of common base current gain. So alpha is greater than 0.908. That means alpha minimum is 0.908, 902. Okay. So right from the beginning, you knew that the transistor will switch between cutoff and saturation. In cutoff, there will be zero current. Now in saturation, I cannot use the beta concept, and that therefore that is not given also. I'll directly find IB, I'll find IC, add them up. You have IE, alpha is found from IC by IE, and thus you can get the value. I think there are no doubts in this question. It's a simple question. So let me know once you are done, then I will take some other questions as well.
Can you explain last point? IC is greater than
Oh,
alpha and Y.
so basically what is saturation in BJT? What is saturation region? So the current gets saturated, right? So you please read that up. Okay. So this is nothing but the same concept which comes from this. Right. So it is the same similar concept here. So I see saturation. The saturation current is uh, that is a limiting current, right? So it cannot be greater than some value. So that is the limiting condition for saturation. So you can read that up. It should be there in books. Okay. So now you see this. This was, I think it's from 2017. Yes, this is a 2017 2 marks question. Okay, and they have given a voltage reference circuit, which I was saying that they no longer give. So voltage reference circuit. Now you see it's a different kind of a circuit, right? So this kind of circuit is what is basically used in ICs and all. And you need to know the current mirroring concept also if you want to use this. Okay, so you see that they have given the relation of IC with the saturation current, because that is needed to find out the value of VBE if it is not given, and VT is 26 millivolts. Okay, and the assumption is that VP will be 0.7. Okay, so now if VP is 0.7, then all these transistors from Q2 to Q32, they are all biased with this 0.7 volts, right? So VBE, so this is what I have written here, that VBE from 2 to 32 are all 0.7 volts, right? And these two terminals are op-amps terminals, right? Plus minus are op-amps terminals. So this will be equal to each other. Okay. Now if I get to find one of the voltage, I can find the other one. So let me see what we can do. So what we can do is we can put a KCL first at this node V minus, and if you put a KCL at V minus, you will arrive at this equation. Just check. V out minus V minus by 20k Okay, and so this one is V out, right? So V out minus V minus by 20k and V minus minus Vp by 5k equals to 0. So this is one of the equations you have. Okay, and you know Vp's value. So now there are again two unknowns. So V minus and V out. Okay, now you can have another KCL at this node V plus, right? You can have another node KVL at V plus, but before that you can do one more thing. What you can do is, if you see the current here, the total current, which the equation that we have written is of the total current, right? So the total current here will be what? Q2 to Q32 are 31 transistors. 31 transistors, right? Q2 to Q32 are 31 transistors. This many. These ones I am talking about. These ones. Sorry. These ones are 32 transistors. 31 transistors. Right? So 31 transistors means the total current. What is the current that is coming? This current, what is it? IC is 31 times IS e to the power what? VBE by VT. So which is nothing but VP. So this one VP by VT. Now if you put in the value, you will be able to. So I see whether they have given or not. So I see IS they have not given. So I think we will have to take some ratio and cancel IS out. So let us arrive at this point at first. So let us stay here. So this is what the equation I have written here. The same equation that is nothing but equal to 31 times Is e to the power QVP by KT is nothing but VP by 0.026. Okay, it is the same thing. Okay, and now you have this current as well. This current, which is IC1, is terminated as IC1, and IC1 will be what? Is e to the power VB1 by VT. But I don't know the value of VB1. I don't know the value of VB1. Okay, I can have one equation as V out minus VB1 by 20k, and that equals to Is e to the power VB1 by VT. That is one more equation I can have. Right? So I think that is what I have written here, right? So equation number 3. So now you have these two equations which you can solve, right? So now you see that VB1 is equals to VP, because this is VB1, right? This is VB1. No, there is a delay, I think. Yeah. So this is VB1, and VB1 is nothing but V plus, and V minus is sorry, VB1 is nothing but V plus, yeah. And V minus we had already found out, right? We have found V minus from this, and something is messed up. 1 second now. Yeah, so VB1 is equal to this thing, and V minus is equals to V plus, right? So this will be equal to VB1. Okay, so in equation number 1, you can substitute V minus as VB1. Okay, and therefore equation 2 and 3 there are two equations, two unknowns, right? So what we can do, we can simply write it like this, that if I compare now, if I compare if you compare this, so you will find that VB1 yeah, so this term and this term are equal here, right? So if you compare now, this term and this term can be equated, these two terms can be equated. Okay, and that is why these two terms are being equated here, and once you equate it, then you will easily get the value of VB1. So in this question, basically you should know how to like first of all the concept of current mirror, and then how to arrive at the point where you can actually solve the circuit. So let me just repeat it for you, otherwise it will get complicated. So what we have done is, we have taken this point as V plus, V minus, this is V plus, and V plus is nothing but VBE1, right? Plus minus VBE1. And now here, from here, I can put a loop. So V minus minus V out by 20, okay, equal to Vp minus V minus by 5. This can be one equation. Now this I can substitute. So now this is nothing but the total current that is flowing, right? So this is nothing but the total current that is flowing from here, and the current is nothing but 31 times Is e to the power Vb1 by Vt. How 31? Because there are 31 transistors here. So total current will be sum of all. 31 transistors here. So total current will be sum of all. Okay. So now you have one equation like this. Now another equation will be from here. This IC1. So IC1 is nothing but Is e to the power Vb1 by Vt. And now what I can do, I know V minus equals to V plus equals to Vb1. So I know if I substitute it here, what will I get? I will get Vb1 minus V out by 20 is nothing but 31 times Is e to the power Vb1 by Vt. And I have the another equation which is nothing but Vb1 minus V out by 20 equals to Is e to the power Vb1 by Vt. Sorry, this will be Vp, okay? My mistake. This will be Vp. Vp upon Vt. Vp upon Vt. Okay? So now from these two equations, again you can equate 31 times Is e to the power Vp by Vt and Is e to the power Vb1 by Vt. And if you now solve these two, you will be arriving at Vb1 equals to 0.78. Okay? Now what is being asked in the question? Output voltage V out. Okay? So once you know Vb1, you can simply apply it, because Vb1 minus V out by 20 equals to Vp is given 0.7 minus Vb1 by 5. You can apply it here and then you will get V out as 1.4 volts. So a bit lengthy question. Okay, so please go and solve it back. I hope this is, I did not confuse you in this, because I know there are multiple steps. So unless you do it, it might be confusing. Okay. So let me know if you are okay with this, then we can quickly do another question. Okay. So let me just check which one can be done. Yeah, this one also is a good MOSFET region of operation question from MOSFET. Okay, let me just do this. So this is a region of operation question from MOSFET. Okay, so they have said that the threshold voltage is 1 volt. Okay, and the state of transistors M1 and M2 is to be found. Okay, now what do you know? You don't know anything else except that there is 2 volts here. and whatever the biasing is given. Now, region of operation for MOSFET is defined by these voltages. So, VDS is greater than equal to VGS minus VT. That means in saturation. If it is less, it is in linear. And if VGS is less than VT, that is the threshold, it is in cutoff. Okay. So, now let me just redraw this question. So, they have biased it like this, and they are asking both the transistors region of operation. So, I should not write it here, otherwise M1, M2. Now, what I'll do is, I'll assume a voltage here, X. Okay, voltage here, X. So now, what will happen, what is, this voltage is 3 volts. They have given it as 3. Yeah, this 3. So now what is this voltage? Plus minus 3 minus X. Right? And this is plus minus 2.5 minus X. Right? So that means what? That means this voltage 3 minus X is greater than 2.5 minus X, right? X is 0, 1, 2, whatever. For a positive values, these positive values, 3 minus X is always greater than X. That means 3 minus X is nothing but VDS1 and 2.5 minus X is nothing but VGS. This we have got. Now the saturation condition is VDS should be greater than VGS minus VT. So if I further subtract 1 volt, it is going to be further less. So 3 minus X is greater than 2.5 minus X minus 1, that is 1.5 minus X, which is always true. Right? So now that means this transistor is in saturation. So I don't know which, oh, they have marked this as M2. So this is in M2 and this is M1. So M2 in saturation. Now for M1 I have to find out. So now I know that this current is the same. Okay, and I will assume the current M1 in saturation first. Okay, so what is happening? ID1 equals to ID2. And I'm assuming both in saturation. So Kn VGS1, that is 2.5 minus X minus 1 volt, VGS1 minus VGS2 minus VTH square equals to Kn. This is 2 volts. VGS1 is 2 volts direct. So 2 minus 1 whole square. Right? So this means 2.5 minus X minus 1 is nothing but 1. And therefore X is nothing but 2.5 minus 2, which is 0.5. Right? So for 0.5 volts, my M2 is in saturation. Right? And now I will check what is about M1. So VGS is 2 volts, VT is 1 volt. That means VGS minus VT is 1 volt. And VDS we just found out X equals to 0.5. Therefore VDS1 is less than VGS1 minus VT, and therefore M1 is in linear region. Okay, so this is how you can find out. Here I think I have written it wrong, which is positive for X less than 2. And actually X should be actually less than 1 for that to be the condition to be true. Okay. Okay. So if there are any doubts in the question, you can ask, or otherwise we'll wrap up. Okay, so if there are no further questions, you can leave the meeting, and all the recorded videos are available in YouTube in my channel. I have uploaded already. Okay, and I think the the NPTEL team will also be uploading those videos. Okay, okay. Thank you. All the best.